Welcome back to video 2 of session 10, which is about Cox Regression Analysis. In the previous video, I showed you how we can compare survival curves, but sometimes we would like to know the risk of a certain conditions in regard an outcome event. For instance, if you have a cohort study, we would like to know whether physical activity at baseline is a predictor of death. As it's a cohort study, we have to take into account survival time, as incidence or new cases is usually measured as how many people per person time or how many cases per person time. Let us assume an example in our dwarf study that we would like to know what are predictors of type 2 diabetes. So we follow up our 60 dwarfs during 20 years and we write down each case of diabetes that occurs in our dwarfs. The follow-up time is for each dwarf the numbers of years until he developed the event. In case that he did not develop the event after 20 years, his survival time in regard type 2 diabetes will be 20, the maximum amount of years of follow-up. This information is basically found in your database. Good, now we'd like to know what are predictors of type 2 diabetes in our dwarfs. So we may assume, predictors probably could be age, BMI in categories, and physical activity. These are probably three of the most important risk factors of type 2 diabetes in human subjects. In our case in dwarfs, we don't know if the pathophysiological mechanisms are the same or not. So we go to analyze, we select here again survival analysis, and here the third element is Cox regression. Here we select Cox regression. The window that opens is very similar than the linear regression windows. So first of all, we select the status. We are interested in diabetes, so we select diabetes mellitus. We move it to the status window, and again we have to define the event. From our database, we know that 0 means no diabetes and 1 means diabetes. So we click on define event, and we tell the program that if the dwarfs is coded as 1 or the variable diabetes is coded as 1, it means that the event has occurred. We click on continue. Now, like in Kaplan-Meier curves, we have to tell what's the survival time in regard diabetes. This is the next variable here, follow-up time regarding diabetes. We select it and we move it into the time window. Here we define the covariate. Similar like in linear regression or multiple linear regression analysis, we decide we'd like to have the age of the dwarfs as a covariate. We would like to have physical activity in a continuous variable in the model, and BMI in categories, as this is our hypothesis. Now we have selected all the variables. As usual in SPSS, we have to do several definitions. We go in categorical and we tell the program that BMI category is a categorical variable, and like in logistic regression, we change it as change to first, so the reference category will be the normal weight dwarfs. Click on change. The other two variables are continuous. We do not have to do anything. So we have changed it. We click on continue. Now I like plots, so we go to plots and we select, for instance, a survival plot, and we like to have separate lines for the BMI categories. So we like to see the survival curves for each BMI category. We move it on the right side of the window by clicking on the arrow. We click on continues and we go to options. In options, we select confidence interval for the hazard ratios and for the point estimate, that's important, and we click on continue. Once we are done, we click on OK, and SPSS does the analysis and shows us several windows. First, it gives us a case processing summary. It tells us how many events occurred, how many were a total number of people, cases with missing values. It tells us the categorical variable finding window, which is another descriptive statistics, how many people observed in each category, not really important. Then it gives you block 0, beginning block. Block 0 is basically the test that includes just a constant and the outcome variable, so also not really important to analyze. Block 1 means is our actual test statistics. First of all, it gives us the omnibus test of model coefficients. That means basically if the p-value is smaller than 0.05, it can be interpreted that adding the variables to the model changes the model significantly. So by adding the three variables age, physical activity, and BMI category, we can get predictors of diabetes, or the model significantly changes. This is basically what we expected, because if you can predict diabetes just on a constant, there's not much point adding covariates to the model. The important information is seen in the variables in the equation window, where we can observe that the hazard ratios for each of our covariates, we have the hazard ratio of age, we have the hazard ratio of physical activity, and the hazard ratio of the three BMI category groups. Hazard ratios are basically interpreted similarly like risk ratio, odds ratio. A hazard ratio bigger than 1 is a risk increase, a hazard ratio smaller than 1 is a risk decrease. We get the confidence intervals as well and the corresponding p-values. As you know, confidence interval much superior to p-values, so it's basically no need to present both in a written result section of your results. Let us have a look at the results of our study. Well, age in the model is statistically significant, a predictor of diabetes. The odds ratio is 1.002, meaning that, the hazard ratio, meaning that for each increase of 1 year in age, the hazard of death increases by 0.2%. This is not much and probably not clinically really relevant. However, we know that dwarfs live very many years, they're up to 3,000–4,000 years old, so this makes that clinically relevant as well. 1 unit increase in physical activity increases the hazard of diabetes by 1.06 times. However, if you have a look at the confidence interval, it crosses 1, it means that physical activity is not a predictor of diabetes. Last but not least, BMI category. This is the reference category. Compared to normal weight dwarfs, overweight dwarfs have a 24-fold increased hazard of diabetes, so the increased risk. The confidence interval varies from 2.969 to 196, so we are 95% sure that the real risk increase or the real hazard of diabetes is between 3 and 196-fold for overweight dwarfs. For obese dwarfs, even worse, a 26-fold increased hazard of diabetes, with confidence intervals from 3.2 till a 208-fold increase. As we see that the confidence intervals are very large or very wide, this means that our point estimate is not very precise. However, it's statistically significant. Finally, we can get some more information on covariates, mean and pattern value. We really can omit it. And then we have the two plots we have selected. This is the important plot where you can see the survival function over time. Cumulative survival at the beginning, 100% all dwarfs were alive. Here we have the survival years until 20 years of survival. We can observe that for the overweight and obese dwarfs, the survival curves are very similar, parallel, and there's a clear difference for the normal weight dwarfs, meaning that normal weight dwarfs are healthier basically in regard to diabetes than overweight and obese dwarfs. Graphically displayed. You know already how you can change the graphs, how you can change the lines, the colors, so feel free to change the colors and the lines according to your own convenience. This is basically how you can run Cox Regression Analysis, how to interpret the results. We could try to improve this model. If you'd like to improve the model, you do it very similarly than in regression models, logistic regression and multilinear regression models. You would remove one variable at a time or add one variable at a time. If the hazard ratio changes more than 20%, then the variable is a confounder and it's good to keep it in the model. If the hazard ratio doesn't change, no need to keep the variable in the model. In the exercise of this session, you're going to have a first exercise where you have to run and interpret a Kaplan-Meier curve, and the second exercise you're going to do Cox Regression Analysis. This was a very brief and simple introduction into survival analysis. I hope in a next course of mine in Basic Biostatistics 3 to go more in details or more in depth of survival analysis. I hope you have enjoyed the Basic Biostatistics 2 course. I hope this is going to be a huge help for your PhD thesis, for your master thesis, your undergraduate thesis. Any problems you have, any questions you have, do not hesitate sending me emails. Thank you very much.